Welcome to Train Signal. You're watching a lesson on network devices. And yes, I said network devices. As in a number of the previous lessons, I keep mentioning various network devices and then tell you we're going to come back and talk about those in a later lesson. Well, guess what? Here's that lesson where we get to go through and look at the various devices that I've mentioned in previous lessons. So the first device that I will mention here, it is something that I actually brought up a couple times. I know I brought it up in the last lesson, and that is something called a modem. Now, the word modem stands for modulate and demodulate, right? The MO is for modulate, and the DEM is for demodulate. And the idea is that these were used for dial-up connections over standard telephone lines. All right, so if we want to have our computer make connection, whether it be to another office or the internet or whatever it may be, over a standard telephone line, it'll be connected with a modem. And the modulation and demodulation that I refer to has to do with the fact that computers work with digital signals and the standard telephone line works with analog signals. So it's the converting between the analog and digital signal. Modems can be integrated onto a system's motherboard, although we don't see that too much anymore because, well, we don't use modems too much anymore. It could be an internal expansion card, right? We talked about that in a previous lesson. We talked about expansion cards. Or it could be what I have illustrated here, which is an external peripheral device, okay, where you connect to one of the external ports. This particular device, I believe, would have connected via the serial port. So that's a modem. The next device that I'd like to mention is something a little bit more modern than the modem, and that is something called a NIC, which stands for Network Interface Card. Network interface cards are used to connect systems to physical network media. Okay, and actually, I really shouldn't say physical network media because there are wireless network interface cards as well, which means it's not the physical media, it's the wireless media. But the idea is these cards are used to get the computers on a network, and it's usually via that network that we would then connect to another office or to the internet. And again, they can be integrated onto a motherboard, so it could just simply be a chip on a motherboard, and then you'll have an external connection port if it's, for a physical wired network. So you might have like an Ethernet port, an RJ45 jack sitting outside the back of a motherboard where it's been integrated. Or it could be a chip for wireless connectivity where there's a little tiny antenna that is actually on the motherboard. It could also be an expansion card. And technically, I don't have it listed here, it could be an external peripheral device. I have seen that as well. Now that's a little bit, weird. You don't see that too much. I'd say the one place where you do see it as an external device would be as if it's a wireless network interface card. I've seen it via a USB connection. And in fact, it's not just a matter of I've seen it. Number one, I'm staring at it right now. My computer has an external USB wireless network card attached to it. But that is something that is fairly common if you don't want to have it internal to the computer. Now here's a couple of devices that I've talked about in previous lessons, and I have them together on the same page here, repeaters and hubs, because they actually are pretty much the same thing. I mentioned in a previous lesson a term called attenuation, and it's the idea where a signal will diminish over distance. Right? I mentioned different types of cables, and they can only transmit a signal so far before the signal attenuates. Well, what we do if we need to transmit a signal further than that cable can handle is we use a repeater. And a repeater is a very simplistic device. It has no sophistication to it at all. All it knows is if I hear a signal come in on one port, I'll yell it back out on the other port. So the example that I gave when I talked about attenuation is I talked about using sound as an example. I talked about if you can hear my voice right now, maybe through the speakers on your computer. As you get further away, you may not be able to hear that signal as loudly or as clearly. And then if you eventually move far enough away from your computer or the speakers of your computer, you won't hear me at all. Well, what we could do to resolve that, if you needed to be that far away from the computer, is imagine if you put another person in between you and the computer. All right, so you have the computer, and let's say that you could get as far as, this is all hypothetical, this is all just made up numbers. Let's say you could get as far as 20 feet away from the computer and still hear and actually be able to comprehend what's being said. That's how far the sound could travel. And you needed to be 30 feet away. Well, what you do is you go grab another person, you put them within 20 feet, so we'll say within that 15 to 20 feet range. They can still hear what's being said, and then they in turn turn to you and repeat what's being said. Right? I'm saying it now, they're hearing it, and then they repeat it to you. And the sound of their voice then makes it to you. That's how a repeater works. Very simple. No sophistication to it. Now, I mentioned that a hub is basically the same thing. Now, you've heard the term hub used in the lesson where we talked about, well, one of them was where we talked about topologies. Talked about the star topology with a hub. A hub is really nothing more than a multi-port repeater. It takes the signal that comes in on any one port, and then it repeats it with a fresh broadcast, fresh transmission, I should say, not to be confused with, because broadcast means something else, but a fresh transmission out all of the other ports. Okay, so a hub is really nothing more than a multi-port repeater. Now, I'm also going to tell you a little something. This is a little trivial piece of information. It's actually an important piece of information, but only if you were trying to become a networking specialist, which is not what we're trying to accomplish here. That is that repeaters and hubs function at what's called the physical layer of something called the OSI model. I am not going to teach you about the OSI model in this lesson. Matter of fact, I'm not going to teach you about it in this course. But if you've ever heard anyone ever talk about the OSI model, and if you've ever heard someone talk about a device being a certain layered device, these devices work at the physical layer, or what's known as layer 1. So these are layer 1 devices. And that's what makes it that there's no sophistication to it. Because there's no sophistication at layer 1. It just means take a signal and repeat it. That's it. If we were to move up a layer in that OSI model and move to layer 2, or what's also known as the data link layer, again, trivial as far as for right now, but in case you've ever heard of it, I figure I'll share with you. We have these two devices here, bridge and the switch. So as I have listed here, is that the bridge operates at the data link layer of the OSI model. It has a simplistic routing table. And that, again, it's kind of hard to explain all this without going into a full, 3 or 4 hours that would be in the networking course on how all of this stuff really works. But for simplicity, let's just say it's layer 2. Forget that I said data link layer. Let's just call it layer 2, right? And we're going to say layer 2 is a little bit more sophisticated than layer 1. And it uses a very basic routing table based upon MAC addresses. And I also have listed here something that says bridges are used to create separate collision domains. And the reason why is because the idea has to do with, if we go back to our topologies, if we go back to thinking about things like the bus topology, you'll notice that that's kind of what I have illustrated here. I have a bus on either side of the bridge. And in a bus topology, you end up with collisions, which is where two computers transmit at the same time and they go out onto that particular segment and there's a collision. Data halts, it doesn't make it where it needs to go until there's a retransmission. And again, way beyond the scope of what we're talking about here. Basically, the idea is, if you take a look at the illustration, you have the 4 computers on the left and you have 4 computers on the right. What happens is when a computer on the left sends out a piece of data, it's actually something called a packet. So it's a packet of data. On that packet, there is a destination address. If the MAC address, which is the actual physical address of the network card of the destination computer, is also on the left side of the bridge, then the data stays on the left side of the bridge. And the 4 computers on the right side don't ever get bothered with it. But if the packet that's been sent out has a destination address, and we're talking about MAC address, that's of one of the 4 computers on the right side of the bridge, then the bridge will go ahead and pass it along to that side. And then all 4 of those computers will also see it. Again, because that's a collision domain. All of them will see it. It travels the entire network. So that's why we say it's a very simplistic routing table that just bases it off of, I know about the computers on the left side, I know about the computers on the right side, and I will just pass information through to the other side as a whole when necessary. And by the way, if there is a broadcast, it will pass that broadcast through. Okay, so another term you're going to see coming up is something called broadcast domains. A bridge does not create separate broadcast domains. If a broadcast is made by any one of these 8 computers, it will be passed through the bridge to all other computers. Now, a switch is basically, by its most simplistic definition, a multi-port bridge. And in the illustration that I have in the bottom half here, the 4 computers up top that are each individually wired into the switch, almost in the form of, even though it doesn't look like it, like in the other lesson, but in the form of a star topology. What's kind of cool is that each computer now resides in its own collision domain, meaning a computer will send information into the switch and it will only go out the port of where the one other computer is. Unless, of course, you have a hub plugged in, like I have illustrated here, which is where you have the switch kind of acting as a switch, but also almost kind of like a bridge, where I have 4 computers in the bottom that are all as part of one collision domain. And if any one of those are the destination address, then the switch is going to send it out that port out to the hub, who will then transmit it out to all 4 of those computers. Now, switches get very complicated, okay? Meaning, in its most simplistic fashion, it's a multi-port bridge. But we will see coming up here that there are other types of switches, more sophisticated switches, that can do just a little bit more than what I've explained to you here. But before we get to those, let's first talk about something called a router. There's another device that we've talked about in a previous lesson, right? I know we were talking about IP addressing, talked about the default gateway pointing to a router. So a router, first of all, it functions at the network layer of the OSI model, which is, again, don't worry yourself about the OSI model. I throw this stuff in there because I want you to know it in case it ever comes up. But we're just going to say it's layer 3. And it is, by the way. I'm not saying we'll just say it. It really is layer 3. And the only thing I really care that you know right now is that layer 3 is a little bit more sophisticated than layer 2. Because routers are used to connect different networks together, and they have sophisticated routing tables, which can determine the best route to get information from one network to another. Now, here's a term I said would be coming up, and that is that routers are used to create separate broadcast domains, which means that computers on one side of a router are not going to receive a broadcast that was sent by a computer on the other side of the router. A router will kill a broadcast. As a matter of fact, a router will kill any unknown destinations. If a router gets a packet and it sees the destination, and by the way, the addresses used by routers are IP addresses, not MAC addresses. If it sees an IP address and says, I don't know what to do with this, it won't send it anywhere. As opposed to the bridge and switch that we talked about previously, if it gets an unknown, it just says, I don't know, I'm just going to send it everywhere. I'll send it out all my ports on the hope that it gets somewhere. All right, so a router does not send unknowns, and it doesn't send broadcasts, therefore creating separate broadcast domains. And the illustration I have here is not a very good one to truly illustrate what a router can do. But when we talk about sophisticated routing tables, imagine that you have a large enterprise that has 40 different networks, and you have a series of routers connecting these networks all together. Or I'll tell you what, let's use the example of, if you go back to the topologies lesson, the types of networks lessons with the topologies, and I talked about WANs, or the mesh topology, where I showed a picture of the United States with the 5 different cities. You have these routers connecting the different buildings in the different cities. And it's the router that will determine that if somebody in Los Angeles is trying to send something to New York, what's the best way? What's the available way? What's the fastest way? What's the most cost-effective way? Routers can do all that. Now, again, as you've heard me say before, there is much more sophistication to truly understanding how routers work. And I invite you, when you're done with A+, to look into networking and learn all about it. Now, I mentioned that switches, they come in many different flavors and they have all sorts of different functionality. Now, the first thing I have listed here is something called a multi-layer switch. And this is a switch, I have it listed here as functioning at the data link layer of the OSI model, just like a regular switch, but also provides additional functionality at the higher layers. Or to be more specific, I'm going to say the most common multi-layer switch might be something called a layer 3 switch, which is a switch that actually can do some routing functionality as well. You can create things like VLANs, virtual local area network, stuff like that. Again, I don't want to get too far out of the scope here. I don't want to confuse you too much because this is not a networking class. But the idea is that you can do both basic switch and routing type functionality. I will tell you there was a device that we used to talk about in the old days called a Brouter. B-R-O-U-T-E-R. Brouter. It's like brunch, right? Brunch is breakfast and lunch all together in one meal. A Brouter is a switch and a router in one. Can perform switch and routing functionality. A content switch is a version of a multi-layer switch, which is used to distribute incoming requests to servers that can handle data in the packets. Basically what it does is it has the ability to look into the actual packet itself, decide what type of content it is, and then see where it should be sent on to based upon the other devices that can handle that form of content. Some advanced switch functionality that we have is PoE, Power over Ethernet, used to transfer electrical power over a twisted pair cable, meaning our Ethernet cable. This is very cool and comes in very handy, okay? Because sometimes you'll have devices, different networking devices. A great example I'm going to give you is a wireless access point. We talked about those in the wireless networking lesson. Very often you want to place those in a location that there is no power outlet. Example I'll give you is like maybe up hidden in a drop ceiling. How often, when you look up above the drop ceiling, how often do you see actual just regular power outlets up there? Almost never, unless you hire a contractor to put them there. So it's very cool being able to go ahead and power those access points right over the same Ethernet cable that you need to connect that access point into your network anyway. Switches also use something, and this is actually switches and bridges, use something called the spanning tree algorithm to help determine the best route when there's more than one. Okay, so it kind of starts to give you a little bit more sophistication to your routing table. Still not making you as sophisticated as a router, but it's a little bit better. And then I also mentioned just a moment ago VLANs, virtual LANs. You can emulate a broadcast domain. Even though you're not using a router, you're only using a switch. So switches, just keep in mind, what I'd really like you to remember more than anything else when it comes to a switch is what I had back on the previous slide about how it's layer 2. It uses very basic routing based on MAC addresses. That's your generic switch functionality. I just thought you should know that switches do come in many different flavors and give you many other options as well. Firewall. That's another term I brought up in a previous lesson. I mentioned the firewall router. The difference between a firewall and a router, because very often they are one and the same as far as the physical device itself, is the functionality. The router is just routing. It's just a matter of figuring out how to get stuff from one place to another. The firewall is what is used to protect and determine and filter what data can get past it. Okay, so even though it's very often one device that's doing both, the functionality is two different things. Okay, firewalls control what data travels in and out, and there's many different levels of sophistication in the firewalls. The most common level has to do with ports. If you remember when we talked about protocols and ports, you can open and close certain ports on a firewall, and then that type of communication can or cannot get through. But there is also content filtering and things like that that can also be done. Now another type of, it's not really a firewall, but it's kind of, it's an edge appliance, so to speak, is something called a proxy server. And this is an old antiquated term, proxy server. We don't have anything that's officially called proxy server anymore. But there are three main purposes to this thing that we used to call a proxy server. And we do still have them. They're just called other things. Like right now in Microsoft world, it's called the Threat Management Gateway. But one thing it can do is it can disguise an end user's actual identity and allow them to use an internal private IP address using NAT, Network Address Translation. I mentioned that back in the IP addressing lesson. It can do something called caching, which is a way of making it that when one client makes a request, let's say out on the internet, right? I want to go to, some web page out there. It goes through the proxy server. The proxy server actually makes the request. When the request comes back, it saves it its own memory so that when a second client makes the same request, it doesn't have to go out to the internet. It just says, oh, here you go. I have this saved here. So you can save on bandwidth. And you can also do a little bit of the content filtering, kind of like I was mentioning with the firewall, where you can decide what websites can and cannot be accessed. Well, here's a device. It's been talked about in a previous lesson, and it's coming up again here. Matter of fact, I've talked about it throughout this lesson, the wireless access point. It's just like a hub. Okay, I talked about what a hub is, but instead of via physical cables, it has one physical cable connection, and the rest of the connections are all made via wireless connections. And I will tell you that I say it's similar to a hub. It can also be similar to a switch. Depending on the wireless access point, it can have switching type functionality instead of hub-like functionality. But then you're getting a little bit crazy with sophistication. So we'll just think of it like a hub. We have our basic DHCP servers and DNS servers, which I've talked about in previous lessons. DHCP is used to dynamically assign IP addresses out on a network. So if your clients want to automatically be assigned their IP addresses instead of you walking around to each one and statically putting it in, you would use DHCP. DNS, I mentioned in previous lesson. A DNS server is a device that will maintain a database of names and IP addresses so that we can be stupid humans and remember things by name, and it will then convert them to IP addresses. And the last thing here before we wrap things up, a couple extra devices. You know, it seems a little obscure with some of these here, but I wanted to make sure they're part of the CompTIA A+ objectives. So we have these voice over IPs, or VoIP phones, which is an IP phone that uses voice over IP, VoIP, technology for placing and transmitting telephone calls over an IP network, such as the internet. Doesn't have to be, though. Could be internally, instead of using the standard public switch telephone network. This is becoming much more and more common in today's world, where we now communicate using voice over an IP network. So our voice can actually be transmitted across the internet to communicate with one another. And then we have internet appliances, and this is kind of a fun one. I almost kind of laughed when I saw this was still on the objectives, because what I think of as an internet appliance, at least in the old day, you'll see here, I also have listed it, sometimes it was referred to as a net appliance. It's a machine that has some specific function, but then it also has built-in web-enabled computer. In other words, it's a device that serves some other purpose altogether, but it has internet connectivity. One of the best examples I could give you in today's world would be some of your smart televisions, right? Some of your televisions or DVD players, things like that, that connect to the internet. So even though the specific purpose of the television is to go ahead and watch TV, it also has internet connectivity, so you can get your Netflix and stuff like that. So, you know, I guess it does make sense that we still talk about internet appliances. We just don't think of them the same way as we used to in the old days, where we had other real strange, weird internet-based appliances. And that does bring us to the end of this lesson on all the various networking devices that we've been talking about throughout the various networking lessons. So hopefully now that's brought some clarity if you weren't clear before when I've mentioned these names and you said, what's he talking about? All right, so there's a variety of them. The one thing I do want to tell you about these network devices, though, you'll notice that for most of these devices, I did not put up an actual illustrated picture of the device itself. And the reason why is because you need to keep in mind that these networking devices are about the functionality, not what they look like. They come in all different shapes and sizes. Almost every device I mentioned could simply be a computer with software representing that device. I could literally take a computer and have two network cards and make it a router. Whereas there are other devices that you can actually like go to the store and buy. It's actually, you know, that's its whole purpose is it's a router. And even those come in all sorts of different shapes and sizes because you have internet routers like we have at home for home connectivity, whereas we have like enterprise like Cisco routers, which will look very different. All right, so that is one thing I definitely wanted to mention before I let you go here, is that I don't want you to think about what a device physically looks like. You need to understand the functionality of that device. And with that, I thank you for watching this lesson, and I will see you in the next one.